microparticle of a particle. Okay, position and momentum cannot be estimated simultaneously, cannot be estimated accurately. Estimated cannot be estimated accurately simultaneously. Accurately simultaneously. Okay, that is the statement. Okay, you got it right. So position and momentum of a particle we cannot estimate simultaneously with a high accuracy. Okay, that is the uncertainty principle. Okay, so suppose we will see small example here. The expression is here. The statement is here. Delta x is the uncertainty in position and delta p is the uncertainty in momentum. Uncertainty in position and momentum. The product of uncertainty in position and momentum is greater than or equal to h by 4 pi. H by 4 pi. This is the expression for Heisenberg principle. Okay. This delta x and delta p is greater than or equal to h by 4 pi, or you can write delta x and delta p greater than or equal to h cross by 2. H cross by 2. Here h cross is equal to h by 2 pi. H by 2 pi. Okay, this is just to simplification we have written h cross here. Okay, that is the, this is uncertainty principle in terms of linear position and linear momentum. Linear position and linear momentum. Okay, linear momentum. Okay, momentum you can write. Okay, this same condition also possible for energy and time. Energy and time, delta E and delta T greater than or equal to h cross by 2 or h by 4 pi. You can write whatever. Okay, after that, this is energy and time. Energy and time. And another case also possible. This is delta J angular momentum and delta T angular displacement, okay, is greater than h cross by 2. So delta J is the what? Uncertainty in angular momentum. Okay, angular momentum. Angular momentum, and delta T is the uncertainty in angular displacement. Okay, what is that? Angular displacement. We can write. Okay, angular displacement. Okay, these three cases we can write. Okay, suppose we have written this one, right? Delta x into delta p. Actually accurate one you have to write here x, then greater than h cross by 2. Okay, that means what? Suppose you are the your particle is moving along the x direction. Along the x direction, particle is moving some along the x direction. So momentum also you have to write along the x-axis only. You should not, delta p means whether it is x direction or y direction, z direction, we don't know. That is wrong way. Suppose if you write position is x direction and momentum is y direction, so this is not right. This is 0. This is not right. Okay. Suppose if you write accurately, this is the correct one. Or you can write delta y and delta py is equal greater than or equal to h cross by 2. Or you can write delta z and delta pz is greater than or equal to h cross by 2. This is correct way. That means you are the finding the particle along the x direction as well as finding the momentum of particle along the x direction. Okay, suppose if you write delta x and delta py greater than or equal to h cross by 2, that means what? Here particle is going x direction. You are finding the position along the x direction, but momentum where you are finding? Along the y direction. Suppose if particle is going x direction, what you will find? Momentum will not be there in y direction, right? Isn't it? Suppose
Yes, sir.
you are going, suppose you are going about Tarnaka road. Suppose someone want to momentum of you along Sikindrabad, you will not find, right? Or you can say simply particle is going along the x direction. So if someone asks where is the which side is particle is going, you will say along the y direction. So what is the momentum? If anyone asks, you will say momentum also along the x direction, right? Particle is x direction, momentum also x direction. That is the correct one. Suppose if you write along the y direction, del, uh, you want to find the movement along the y direction. but particle is x direction. There is no particle y direction, right? That means there is no momentum along the y direction. Suppose if you write this way, it is not correct. Okay, it is not correct, but convenient way, but we are writing this way, but you have to write here x, then only it is accurate. Statement is, equation is correct, otherwise it is not correct. Okay, momentum having direction, right? So always if you write expression delta x and delta px greater than or equal to h by 4 pi, or you can write h cross by 2. You write this way. This is correct way of representing the Heisenberg uncertainty expression, right? Now you got it, right?
Yes. Yes, sir.
So particle is now in this condition, in this statement, particle is going along the x direction. We are finding the momentum also x direction. Both are x direction only. That is correct way. Okay. Always you write this way. Okay. Expression, three expressions, it is possible for energy time, and also angular momentum and angular displacement, and also linear, this is linear position and linear momentum. Delta p is the linear momentum. Okay. Delta x means uncertainty in the position. Uncertainty means what? What do you know about uncertainty means what? What is the meaning of uncertainty? Uncertainty. What does it mean? Uncertainty means what, do you know? What is the meaning of uncertainty? Anyone? Otherwise?
It is not perfectly defined.
Yes, very good. Okay. That is error in a error in original value or some, it is not, we are not finding exact value. Okay, some error. That means delta x is uncertainty in position, means there is a error in finding the position. There is a error in finding the position. Delta p means uncertainty in momentum. That means there is a error in finding the momentum value. That is the meaning of delta p and delta x. Okay, you got it right now. You got it right.
Yes. Yes. Yes, sir.
Uncertainty in momentum, uncertainty in position of any particle is greater than or equal to h by 4 pi. So this value, uncertainty, error in position and error in momentum is maybe equal to h by 4 pi or greater than h by 4 pi. This is some constant value. This is also constant value. You will have some error. Okay. Suppose what is the h by 4 pi value? Anyone calculate? Suppose if you calculate, h is equal 6.62 10 power minus 34 joule second, and this is 4 into 3.14, right? Uh, 12 means 6 by 12 into 10 power minus 34. Okay, 6 suppose a zero point 0.5 something like you will get, right? 0.5 something else. Okay, like this much, there is a error of this much, there is a error of this much, or maybe greater than this much error we will get. Okay, if you going to find out this product or these values, okay, we will get the error of maybe equal to h by 4 pi or greater than to h by 4 pi error will get of product of these two errors. Okay, that is the uncertainty principle. Okay, now we will see small example, then you will clearly understood this what is the uncertainty principle means. Okay, suppose you are here. Okay, you are sitting here. Okay, you are sitting here. Okay, so some person is dancing here. Okay, some person is dancing here, some person dancing is here. Okay, generally you will observing in your TV or something else. So can you see simultaneously these two persons? Can you see simultaneously?
No, sir.
No,
At
sir.
an instant of time, we cannot see these two simultaneously. Sometime we will focus this person on this person, sometime we will focus on this person, right? Here also same thing, we cannot find position and momentum simultaneously. Same thing, we will see one example also. Here we will see some small example. Okay, suppose here we have a small slit here. Okay, here we have a small slit. Okay, here we have a screen, suppose screen. So here we are sending a some electron from this screen, some this slit. Okay, if you send the slit, okay, you will get the diffraction pattern, right? This is a very fine slit. You will get the diffraction pattern. If you plot this diffraction pattern, you will get a like this, right? Okay, like this you will get, isn't it? So this is the electron possibility of electron moving only this much, right? This much only move. Okay, right? Here only slit is this much, means the space is only available, only small space is available for electron moving along the y direction. This is y direction. Suppose this is I will write directions. This is x and y. So here along the y direction, electron momentum is only limited to this slit width, right? Suppose slit width is d. Suppose d. Only this slit width only the electron move, because beyond this slit width the electron will be blocked, right? So if you observe this one, okay, if you observe here, the diffraction pattern here getting this much. Okay, the diffraction pattern is this much you are getting. That is suppose delta, suppose that is py, delta py, or the here electron momentum along the y direction is very small, but if you observe diffraction pattern along the on the screen along the y axis, along the y direction, it is spread out, right? It is spread out. So here slit width is small, but here along the y direction diffraction is very large. Slit width, you are you following this one? So this is just a thought process. Okay, it's not an experiment, just a thought process. So here slit width is small, d is very small. Okay, that means x is very small. Position of electron is very small. Here momentum, if you going to find out momentum, here very large. Okay, that is diffraction pattern. Your width is small, you are getting diffraction pattern large. So that means suppose if width is small, that much only if you get the diffraction pattern, that means you are getting accurately how much position and same amount of momentum you are about to calculate. But here position is small, but momentum is large. So if you're going to find out the uncertainty in the momentum, that will become a large value. That will become a large value. So you want to decrease the uncertainty in momentum. So you have to, what you have to do? You have to increase the slit width. If slit width is large, that the diffraction pattern is small, right? Is it true or wrong? It is not, means if you increase the slit width, you will get the fine diffraction pattern. If slit width is small, you will get the higher diffraction pattern. That means, so in this case, slit width is small, you are going to find out the uncertainty momentum here very large, because for small slit width you are getting higher diffraction pattern. Similarly, you want to reduce the uncertainty in momentum, you have to increase the slit width. That time there is a uncertainty increasing in position of a electron. So this is the simple example how uncertainty is arising while calculating momentum and position. Did you follow this example? I don't know whether you followed or not. Very simple.
Followed, sir.
Suppose just I will explain. Here slit width is small. Okay, slit width is small. We are getting the higher diffraction pattern. Okay, so here electron only this much only. There is a momentum of electron only. The slit width only. But if you see here, the position of we are finding the momentum of a electron, that is diffraction pattern is large. Okay, delta p is large here, but small slit width is small here. Width is small, diffraction pattern is more. That time, if you are going to find out uncertainty in momentum will be higher. Okay, error will be higher in momentum. So you want to reduce the error in momentum, you have to increase the slit width. You want to reduce the error in momentum, but you have to increase the slit width. That time you will find error will increase in momentum. So that is why you cannot estimate simultaneously uncertainty in momentum and uncertainty in position. So you cannot, the statement is saying you cannot estimate position and momentum of any particle simultaneously. Okay, that is simultaneously with very accuracy. Okay, with accuracy we cannot find out position and momentum of a particle. This is the uncertainty principle. Is this clear everyone? Uncertainty principle, you got it right?
Yes, sir. Yes, sir.
So if you have doubts, you can ask. Very simple. Okay. The statement is position and momentum of a particle you cannot estimate simultaneously with high accuracy. Okay, the statement is delta x and delta px is greater than or equal to h by 4 pi, or you can write h cross by 2 also. Okay, h cross means h by 2 pi. Okay, this is the statement. Okay, suppose the case 1 is, suppose we will see case 1. Suppose delta x is tending to 0. The position is tending to 0. What is the momentum delta p? Becomes to infinity, right? And similarly case 2 also, the position momentum is tending to 0 or equal to 0, and the finding the uncertainty in position becomes infinity. That means what? This delta x delta p always be in some value or some not equal to 0, then only we can estimate the uncertainty in other component. Okay, this is two special case. And what are the applications? What are the applications? This is also very important. Okay, what are the applications? First one you can say, suppose this is the nucleus and electrons revolving around the nucleus, right? You can estimate the radius of this electron. Okay, Bohr radius you can estimate. Bohr radius you can estimate. And you can say non-existence of electron in the nucleus. Existence of electron in the nucleus. Okay, how you will estimate this one? Suppose we also know electron will not exist in the nucleus. Electrons always revolve around the nucleus. So using this Heisenberg uncertainty principle, we can say electron always revolve around the nucleus. This will not exist in the nucleus. How you will estimate? So using this formula, delta x and delta p, okay, are greater than h by 4 pi. Using this formula, suppose electron will be in the nucleus, the position will be 0, right? Position is 0. So it is not staying at in this position. It is electron also having some momentum and velocity and momentum. That is having some velocity and momentum. Using this formula, you can estimate x, position x, how much distance this electron is revolving around the nucleus. From there you can say non-existence of electron in the nucleus, or electron will not exist in the nucleus, or you can say, and also you can estimate the, what you will estimate, Bohr radius and nucleus also present. What is this one? One second. So here one more application, you can also estimate the binding energy of the atom, and also you can estimate the protons will exist in the nucleus. Protons will exist in the nucleus also, you can estimate. And binding energy of the atom. Binding energy of the atom also you can, binding energy of the atom also you can estimate. The applications are these. Binding energy means what? Anybody? Binding energy? Binding energy. Binding energy, please. See the question. Binding energy. Binding energy. Binding means what? Binding, at least tell me what is the binding.
Combining.
Yes.
Joining.
Yes. Bind. See
Touching.
here. So binding energy. Suppose nucleus is there. Here this is the nucleus and electrons are revolving around the nucleus. So how these are bind to nucleus? The energy, binding energy means, suppose this electron is attracted with some energy, right? This is binded with bound with some energy. Suppose you want to pull out this electron, you have to apply some energy to take out this electron. That energy only binding energy. So binding energy means the electron which is you want to, if you want to remove electron from the nucleus, you have to apply some energy. So that energy we are calling binding energy. The amount of energy required to eject the electron or take out the electron from nucleus, that is the binding energy. So this electron is bound to nucleus with particular energy, that is only binding energy. Okay, is this clear? Just you read question, you will understand. Okay, is this clear now?